Let us discuss another question from engineering mechanics. Here you have a disk which is kept between two horizontal rails, and it is known that these rails have velocities as given. So now, because of this, actually, this disk is under plane motion. So whenever a body is in plane motion, so what we do, we write down everything with respect to a center. So let's first have the center velocity as v. So here is the center velocity. So center velocity as v, and planar motion body is the planar motion can be always visualized as both translation as rotation. So this is the center of mass velocity, translation velocity, and then you have the rotation motion, which is omega, which I have written like this. Okay, so this is how I have written v and omega. Okay, now velocity at any point on the disk can be written in terms of v and omega. So velocity of point B is nothing but velocity of point V is basically, because of this translation part, the velocity of B is v plus the omega also gives a velocity in this direction, tends to have a velocity in this direction. So v plus r omega. Okay, where r is the distance from the center to the B. So this is v plus r omega, the translation part plus the rotation part. Okay, so I mean, what you can do is, if there is no omega, the entire thing will move, all the points will move with v. So that part is v, plus if v is 0, let's say, then due to omega only, the velocity of B will be undergoing a purely fixed axis rotation. Then the velocity of V will be v is equal to r omega. So now combining these two is v plus r omega. So you can visualize like this. Now A is at the top. Okay, so the velocity of A is, because of the translation, it's v, moving right, but because of the rotation, it's towards left, so minus r omega. It's in opposite direction because r omega is in this direction, so that's why minus. Now it is given that the rails don't slip, basically the disk don't slip at A and B, so the velocity at B and as well as the horizontal velocity at both top and that should be 0, and there is no relative velocity at the point of contact at A and B. So the velocity, if there is no relative velocity at A and B, then the velocity of B should be equal to 4, and velocity at A should be equal to 2, because there is no slipping, there is no relative motion. Slipping means there is relative motion, so no slipping means there is no relative motion. So we need to find out omega, and v is something which we don't want. So v is the center velocity, r is given as 0.5, so 0.5 omega is equal to 4, and this is v minus 0.5 omega is equal to 2. So let's subtract this 1 and 2 so that v gets cancelled. So 0.5, that is subtracting 1 minus 2, we get 0.5 omega minus 0.5 is omega, and this is okay. Now here there's a mistake here. So at A, the velocity, the positive velocity v minus r omega represents towards right, because v is towards right, r omega is towards left, so the net v minus r omega is towards right, but what is given is 2 is towards left, so we have to have a minus 2 here in order to make it towards right. So this is minus 2, and when I subtract, I get 4 minus 2, it is 6. So you have to understand why we have written minus. Otherwise, one thing what you can do is to due to rotation, it's r omega towards left, and due to translation, it's v towards right. So r omega minus v is effectively towards left. So r omega minus v is towards left, and that is 2. So you can just write in this way, because velocity of A is towards left, or you can just write down in terms of formula, and that is, if it is right, and you can put minus here. So both are same. Okay, So we forgot the minus before. So the answer is 6 radians per second anticlockwise. Thank you.